Hi students, so now we are going to see the topic called surface chemistry. So this chapter consists of mainly adsorption, colloids, you also have catalysis and enzymes. So first we are going to see adsorption. So let us see what is adsorption. First let us see what is absorption, then adsorption. Okay, now let us go to video. Absorption. This is, we come across like many subjects. You would have come across absorption, right? Absorbing. For example, if I put say sponge in water, so the water will penetrate. Another example, plants. Plants absorb water and minerals from the soil, and it will take part. It takes to the different, leaves, stem, and everywhere of that plant parts, right? So this is an best example for absorption. Okay. Now what is adsorption? Now let us see what is adsorption. AD. See, if the absorption occurs only at the surface, if it happens only at the surface, then it is known as adsorption. So absorption, which goes throughout, whereas adsorption only happens at the surface. Okay, only at the surface if it happens, then it is called adsorption. Okay, and most of the reactions, if you see, all are surface phenomenon. So it happens at the surface. For example, I am dissolving salt in water, or I am dissolving sugar in water. So whatever you are dissolving, it happens at the surface. So since it occurs at the surface, it is called absorption. Okay, absorption occurs at surface, so it is called adsorption. So if it occurs, most of the reactions, it takes place at the surface first rather than entering inside. Okay, so that is what we are going to see now. Okay, now what are the things involved in the adsorption? So that is what we are going to see. Adsorbate. Adsorbent. What is adsorbate? Solute. What is adsorbent? Solvent. Okay, adsorbate, adsorbent. So adsorbate is a solute, solute is a little quantity, and adsorbent is more quantity. Is that okay? So solute plus solvent will give you solution. Adsorbate plus adsorbent will give you adsorption. Okay, so now we are going to see what is the difference between adsorption and absorption. Okay, so let us see the difference between adsorption and absorption. Okay. Difference between adsorption and absorption. So adsorption is a surface phenomenon, means it happens only at the surface. So it's a surface phenomenon. Whereas absorption is bulk phenomenon. It happens throughout. Bulk phenomenon. Okay. Right. So now, adsorbate will get adsorbed on the adsorbent. So that is the definition. So definition can be the difference. So this happens at the surface. So that is why we say it as surface phenomenon. This happens throughout. So it is called bulk phenomenon. So we can give an example for adsorption. So silica gel is a very good adsorbent. So if you are buying say new say water bottle or lunch box, inside you would have seen one packet, okay, white color packet, which consists of silica gel, which is an adsorbent. So those silica gel, what it does, it actually absorbs the moisture. It won't absorb, it adsorbs. Okay, it absorbs the moisture. So we use that silica gel is an adsorbent used. So if you use anhydrous calcium chloride, anhydrous calcium chloride, so what it does, actually it absorbs the moisture, absorbs. So there is a difference between adsorb and absorb, okay. So for example, if this is the adsorbent, this is an absorbent, okay. So the adsorbent, on the surface of the adsorbent, adsorbate will come and sits, or it will get adsorbed on the surface, you can see. Whereas here it penetrates inside. So I hope you guys understood how adsorb, what is the difference between adsorption and absorption. Adsorption occurs only at the surface. You can see on the surface of the adsorbent, adsorbate is actually getting adsorbed. Whereas here it enters inside. Outside also it will be there. So it doesn't mean that it won't be there. It will be there on the outside also and inside also. So that is the difference between adsorption and the absorption. Okay. Hope you guys understood this difference between absorption and adsorption. Okay. Now purely you are going to see about the adsorption. Okay. So what we saw, sum up, adsorption occurs at the surface, so it is called surface phenomenon, which involves adsorbate and the adsorbent. So put together, adsorption takes place. Is it okay? Now I also gave you the example silica gel, which adsorbs the moisture from the atmosphere. Is it okay? Now let us go on to next mechanism. Okay, the mechanism how the adsorption takes place. Is it okay? Mechanism of adsorption. Now this is adsorbent, for example. So now your adsorbate is going to get adsorbed, you know, on the surface, right? On the surface it will come and get adsorbed. Now in this mechanism, what is the mechanism followed in this adsorption? So that is what we are going to see. So I can write here delta G naught is equal to delta H naught minus T delta S naught. So delta G naught is equal to delta H naught minus T delta S naught. So delta G is the Gibbs energy, delta H is the enthalpy, and delta S is nothing but entropy, and T is temperature, you know that. So this is the thermodynamic, according to the thermodynamics, delta G is Gibbs energy, you know. Delta H is enthalpy, delta S is entropy. Now adsorption is an exothermic, okay, it's an exothermic reaction. So delta H is negative, okay, it's an exothermic reaction, delta H is negative. And since the adsorbate is coming and getting adsorbed, what happens to the randomness? The randomness decreases. So actually for the spontaneity, so first let us discuss about the spontaneity, then you will understand this, okay. Spontaneity, the reaction to be spontaneous, delta G should be negative, delta H should be negative, delta S should be positive. On the whole, we always decide only based on delta G, okay. If the delta G is negative, it is spontaneous process. If the delta G is positive, it is non-spontaneous. If delta G is 0, the system is at equilibrium. Is it okay? Now in the adsorption process, it is an exothermic process, so delta H is negative, not a problem. And what about the randomness? Since the adsorbate is getting adsorbed, the randomness decreases. So delta S supposed to be the positive, now it decreases, no, so it becomes negative, okay. So now delta G is equal to delta H minus T delta S, right. Now since this term is going to be negative, so this term becomes positive, right. Partially it becomes positive there, Now how? Then the delta G should be negative, only then it is the spontaneous process, and adsorption is a spontaneous process. Then how delta G can be negative? Because there the delta S term becomes positive because the randomness is decreasing. So in order to make the delta G negative, the delta H should be highly negative. This is a very, very important point. Highly negative. Okay, highly exothermic. So only because of that the delta G becomes negative, and thus the adsorption is spontaneous. Okay, once again I will repeat. Delta G is equal to delta H minus T delta S. Actually, according to the spontaneity, delta G should be negative, delta H should be negative, delta S should be positive. But what happens is this, delta H is negative because it is an exothermic process. But randomness, what happens is the randomness decreases. Because of the adsorption, the randomness decreases. Since the randomness is decreasing, obviously what happens is delta S decreases. So since delta S is decreasing there, it becomes a positive value there. But in order to make delta G negative, delta H should be highly negative. Okay, only then the adsorption can be a spontaneous, and obviously it is spontaneous. So delta H should be highly negative, therefore delta G becomes negative. Okay, hope you guys understood. Yes. Now we will see next types of adsorption. So now we are going to see types of adsorption. Okay. Now let us see types of adsorption. Okay. Physisorption, chemisorption, so let me give you as the difference between itself so that it will be easy for you when you compare and study. Okay. So physisorption. So what is physisorption, ma? Physisorption is also known as physical adsorption. Chemisorption is also known as chemical adsorption. Okay. So here the first point we are going to discuss about how the forces are involved. Only van der Waals forces involved. Okay, in physisorption what type of force is involved in the adsorption? Only weak van der Waals force, it will be weak only. Okay. And here the specific forces are involved. Specific bonding. Specific bonding means it can be ionic or covalent, right? Okay, ionic, covalent, so like that. So only van der Waals force is involved in the physisorption, whereas in chemisorption specific bonding is involved, that is ionic or covalent or coordinate, so like that. So if it is ionic, it cannot be covalent. If it is covalent, it cannot be metallic. You understand? So chemisorption, so specific type of bonding. Okay. So how much heat is released? You know it is an exothermic, no? So how much heat is released? Here 20 to 40 kilojoules per mole is released. Okay. As energy. Whereas here 80 to 240 kilojoules per mole will be released. Okay. So weak van der Waals force is involved, only specific bonding there it is involved. So 20 to 40 kilojoules per mole is released, whereas there 20 to 240 kilojoules per mole is released there. Is it okay? Now third point under physisorption. When pressure is increased and temperature is decreased. Temperature is decreased. This shows when pressure increase and temperature is decreased, adsorption is maximum. Adsorption is maximum. So here if you see, when temperature increased, adsorption first increases, then it decreases, okay. So when the temperature is increased, adsorption first increases, then it decreases, okay. So if you plot a graph, okay, for this pressure and extent of adsorption, okay. So it becomes, okay, I can put the extent of adsorption this side. So you will get a graph like this, okay. So initially x by m stands for extent of adsorption. X is the amount of adsorbate and m is the mass of adsorbent, okay. So we are assuming that adsorbate is a gas and adsorbent is a solid, okay. So as the pressure increases, what happens? The adsorption increases and then it becomes constant. Whereas here what happens is, okay, initially it increases, it goes to the maximum, then decreases, okay. So why it reaches the maximum and then decreases? You know exothermic reaction, no? Adsorption is the exothermic reaction. So definitely some amount of heat will be released, given out, correct. So as the temperature increases, adsorption increases, it reaches the maximum, and after which there is no much energy. So what happens is it loses. So that is why you are getting a graph like this, okay. For physisorption this is the graph, for chemisorption this is the graph, okay. So as the pressure increases, adsorption should increase, but it becomes constant after some point of time. That we will be seeing in the next videos, okay. So here what happens in chemisorption, when you increase the temperature, extent of adsorption will increase, but it reaches the maximum value and then decreases. Because it is an exothermic reaction, energy is given out. So that is the reason, but it reaches the maximum value, no energy, so it decreases, okay. So now here what type of layer is formed? Multi-molecular layer is formed. What do you mean by that? For example, let us take this is adsorbent. So randomly multi-adsorption takes place. Multi-adsorption like this. Only weak van der Waals force is involved, right? So what happens is randomly it gets adsorbed. There is no uniform adsorption taking place, no, randomly it is getting adsorbed. So we can say that multi-molecular layer is formed. Whereas in chemisorption, unimolecular layer is formed. Why? Why unimolecular layer is formed? Why unimolecular layer? Because adsorption is so specific, no? So chemisorption is so specific in nature here. So if this is adsorbent, so only one type of layer can be formed. Since, say I told you, no, so it could be like ionic or covalent, any one type of bonding is possible. So uniformly it can form only one type of layer, okay. So here only unimolecular layer is formed, whereas in physisorption multi-molecular layer is formed. Is it okay? Understood? Some general points are there, that alone we can see. So at high critical temperature, adsorption is maximum. So at high critical temperature, adsorption is maximum. What is critical temperature? The temperature above which the gas cannot be liquefied. The temperature above which the gas cannot be liquefied is nothing but critical temperature. So those gases having high critical temperature can be liquefied faster. Is it okay? And another point is, those gases can form hydrogen bonding. Okay, or I can tell you like which is highly liquefiable. So which gas can be liquefied? Those which can form hydrogen bonds. Okay, so basically I can narrow down the point to be, those gases can form hydrogen bonding or highly liquefiable gas. Liquefiable gases can be adsorbed faster. So what do you understand from this is, those gases can form hydrogen bonds, can be adsorbed faster. Similarly, those gases can form high critical temperatures. Okay, those can form high critical temperatures. Those have high critical temperatures can be liquefied faster, or I can tell you that it can be adsorbed faster. So these are the general points. Is it okay? A small recap of physisorption and the chemisorption. So we saw the types of adsorption, physisorption and chemisorption. So only weak van der Waals force is involved, whereas in chemisorption specific forces are involved like ionic bond or covalent bond. Here how much heat is released? 20 to 40 kilojoules per mole is released. There it is 80 to 240 kilojoules per mole is released. So when temperature is increased and when the pressure is increased and temperature is decreased, adsorption is maximum, and you can see the graph also. But at one particular stage it becomes independent, that I will explain later. And in the case of chemisorption, when the temperature is increased, adsorption increases first and then it decreases, because it is an exothermic, the energy is lost, so it decreases. Multimolecular layer is formed in the case of physisorption, unimolecular layer is formed in the case of chemisorption. And these are the general points. High critical temperatures, the adsorption is maximum, and hydrogen bond, those gases can form hydrogen bonding, and highly liquefiable gases can be adsorbed faster. Okay, hope you guys understood. Thank you.